In today's video, we're going to be talking about the chain rule, which is a strategy we can use to solve certain derivative problems. So the chain rule is a little bit weird compared to the other rules that we have for solving derivatives, such as the quotient, power, and product rule. Essentially, if we have a function, say, I don't know, square root of x plus 7, we can clearly define two distinct functions in here. We have x plus 7 as a function, but we also have this outer function here. This square root is also its own function. This function, of course, being the square root of x, or whatever you want to put inside there. In this case, we have the variable x inside of a square root. So there's a very distinct outer function, right, outer, and also a very distinct inner function. So whenever we have a problem that looks something like this, we have to use the chain rule to solve that problem. The outer function will always be our f of x, and the inner function will always be our g of x. Knowing this, we can apply the chain rule to solve functions such as this. The chain rule is as follows. The derivative, d dx, of some function f of g of x, and this notation is just saying that we have a function within another one, such as what we have up here, f prime with g of x inserted into f prime times g of x, or g prime of x, sorry, g prime of x. This is the chain rule, and we're going to use this chain rule to solve some example problems, because I'm going to be honest, this doesn't really help me much. Examples will help me a lot more. The chain rule is rewritten up here in case you want to reference it while we do the video. Let's do 4 examples so you can get the hang of the chain rule. Example number 1 will be the one that I showed here just a minute ago. We want to find the derivative of the square root of x plus 7. What is this derivative equal to? Well, let's establish 2 things. 1, we need to establish what the outer function is, and 2, we need to establish what the inner function is. And we talked about that just a minute ago. This little x plus 7 here is its own function, but it's also distinctly inside the function square root of x, as denoted as such. We have a very clear inner and outer function, so we know which will be our f of x and which will be our g of x when plugging into the chain rule. Let's write that down here. The outer function is the square root of x. And the inner function is x plus 7. Now, in order to use the chain rule, we need to both find f prime of x, in other words, the derivative of f of x, and g prime of x, also known as the derivative of g of x. So let's do that real quick so that way we can just plug them in. First of all, f prime of x, also known as the outer function, is the derivative of the square root of x. So how can we find the derivative of the square root of x? Let's do that up here. The derivative of the square root of x is the same thing as the derivative of x to the 1/2 power. Anything raised to the 1/2 power is the same as square rooting it, and we can use this to solve for this derivative. Using the power rule, which we learned in another lesson, linked up here if you'd like to learn more, tells us that we just need to bring down this coefficient, or this power to the front, and then subtract 1. So this derivative is equal to 1/2 x to the negative 1/2 power. So f prime of x is 1/2 x to the negative 1/2 power, which is also equal to 1 divided by 2 times the square root of x. This may look a little better to some of you, and yeah, it's a little bit less of a mess, so I'm going to use this. Now, the derivative of x plus 7, also known as g prime of x, is equal to 1. And let me show you why it's equal to 1. Up here, we can solve it for x plus 7. We can split these two by the addition sign. That's one of the properties of derivatives that we learned in my video about properties of derivatives, which you can watch here if you'd like. And we can solve for each of these derivatives individually and then combine them at the end to find the derivative. One of the rules of derivatives is that a constant derivative is always equal to 0, so we don't even have to worry about that. And the derivative of x is just equal to 1. So the derivative of x plus 7 is just equal to 1, so g prime of x is just equal to 1. Now let's apply our chain rule. First, we need to plug g of x into f prime. This is f prime, 1 divided by 2 times the square root of x. So this is equal to 1 divided by 2 times the square root, and we need to replace x with g of x. Our g of x was this x plus 7. So inside our little square root here, we just had to write x plus 7. And then, at the end, we need to multiply all of this by g prime of x, and g prime of x is just 1. So we can just multiply this all by 1. So our derivative is just equal to 1 divided by the 2 times the square root of x plus 7, because multiplying by 1 doesn't actually change anything. And that is the answer to the derivative of the square root of x plus 7. Now I will admit, this example you can solve much more easily without the chain rule, but I wanted to use this as an example because you could solve it with something other than the chain rule, and we're just getting warmed up. These next three examples require using the chain rule to solve. So let's do those now. Our second example will be finding the derivative, d divided by dx, of x squared plus 1 to the third power. What is this derivative equal to? Let's talk about it. So once again, we need to establish an inner and outer function. And fortunately for us, this has a very distinct inner and outer function. The obvious one here is that x squared plus 1 is the inner function. It seems to be inside of this function, inside of the parentheses. The outer function might be a little bit trickier, but if you're curious what it is, it's actually this right here, this cubed. So let's write that down here. The outer function and the inner function. So we already established the inner function is x squared plus 1. We know that. But this outer function is a little bit trickier to find out. I told you that it's this cubed, and just like in the square root, it's simply just x cubed. If we were to plug in our inner function to our outer function, we would get this function. So that's basically what's going on here. Once again, we need to find f and g prime of x in order to plug that into the chain rule. So first, let's do f prime of x because it's pretty simple. F prime of x is equal to 3x squared. By the power rule, we take this 3 to the front and make it our new coefficient, and then subtract 1 from the power to get 3x squared. Our g prime of x, also known as our inner function's derivative, is also very simple. This constant, by the constant rule, will turn into 0. The derivative of a constant is always 0, and this x squared can be solved with the power rule. We bring our power to the front and turn it into a coefficient, so this turns into 2x, and then we subtract 1 from the power, 2 minus 1. So this derivative is just equal to 2x, and technically to the first power, but anything to the first power is just itself, so we don't need to write that. Now that we have everything, we can plug this all into the chain rule, so let's do that now. First, we need to write down f prime of x. This is 3, and then in parentheses, we need to put in g of x, which is x squared plus 1 down here, x squared plus 1, and that is all squared. As you can see, we replaced our x value in our f prime of x with the inner function x squared plus 1, and that's what we're doing here. And then we need to multiply g prime of x to this function here. So that's just 2x. This whole function is being multiplied by 2x. Simplifying this down, our final derivative by using the chain rule is equal to 6x times x squared plus 1 squared. And that is the derivative. Example number 3. We are trying to find the derivative with respect to theta. Now, if you're wondering what's going on here, instead of writing d dx like usual, I wrote theta because we're doing this derivative with respect to a different variable, and in this case, it's going to be theta. The notation is just slightly different. It doesn't actually change the problem. Anyway, we're finding the derivative with respect to theta of sine 4 theta plus 2. What is this derivative equal to? So once again, we're going to want to establish our inner and outer function, and I feel like it's pretty clear in this example. We have a very clear inner and outer function, so we definitely need to use the chain rule. Inside of our sine function, we have 4 theta plus 2, and outside we have the function of sine, of course. So our outer function is equal to sine of theta, and our inner function is equal to 4 theta plus 2. Now, once again, we need to find the derivative of both the outer and inner function. This, of course, being f prime of x. The derivative of sine of theta is cosine of theta. That is one of the derivatives you really should memorize. It's a very simple one, of course, but you absolutely need to know this one. It's very important because it comes up a lot. And g prime of x, aka the derivative of the inner function, is equal to 4. The derivative of a constant is always 0, and by using the power rule, we have a power of 1 here. We bring that 1 to the front, then we subtract 1 from it, so we have 1 times 4 here, and then theta to the 0th power. Anything to the 0th power is just 1, so we just have 4 times 1, which is equal to 4. So that's why g prime of x is equal to 4. Now we just need to apply the chain rule. First of all, our f prime of x is equal to cosine. Inside that, we need to put g of x, which is this inner function here, which is just 4 theta plus 2. Oh, 4 theta plus 2 with a green parenthesis for consistency. And now we just have to multiply all of that by g prime of x, which is just equal to 4. And I could put times 4 over here, but I think it just looks nicer to write the 4 here as a coefficient. It would equal the same thing. So this is the derivative of sine 4 theta plus 2. We're going to do one more example for this video. For our last example, we want to find the derivative with respect to x, don't worry, we're going back to x like usual, of e to the negative x squared plus 3x. What is this derivative equal to? Now I understand this probably looks a little intimidating, but it's not too hard and we'll walk through it together. Once again, we need to establish an inner and outer function, and I think this is a little less clear than some of the examples we've done before. But remember, when we want to use chain rule, we're just looking for a function within another function. So as you can see, we have this x squared plus 3x within the function e to the x. So e to the x is our outer function, and our inner function is negative x squared plus 3x. Let's write that down here. Our outer function is equal to e to the x, and our inner function is equal to negative x squared plus 3x. Knowing this, we can now find the derivative of each of these and then plug it into the chain rule once again. First of all, f prime of x, in other words the derivative of the outer function, is equal to the derivative of e to the x, and the derivative of e to the x is just e to the x. This derivative is probably the single easiest one to remember, and you should absolutely know it. It comes up quite often. Now our inner function is going to be, well, kind of by default a little bit harder. So our g prime of x, aka the derivative of our inner function, is just equal to negative 2x plus 3. Both of these can be solved by the power rule. We bring this 2 down to the front, and that becomes our coefficient, and then we subtract 1 from this power. So then we get negative 2 times x to the first power, and remember, anything to the first power is just itself. So that turns into negative 2x. 3x is also solved using the power rule. We have a little invisible power of 1 here that we bring to the front. Remember, anything to the first power is itself, so we can put it there, but we don't have to. 3 times 1, of course, is just equal to 3, and then when we subtract 1 from this power, we get x to the 0th power. Anything to the 0th power is just equal to 1, so we get 3 times 1, which is just equal to 3. Now that we have everything, we can just plug it into the chain rule once again. This starts to get repetitive really fast. So our f prime of x is just e to the x. So we're going to put e here, but remember, we need to plug in g of x for wherever x is. So we just need to plug in this inner function back up there. So this is equal to e to the negative x squared plus 3x. And then we just need to multiply all of that by g prime of x, which is just down here, and that's equal to negative 2x plus 3. And this is the derivative of e to the negative x squared plus 3x. See, not so bad. Just kind of a repetitive rule that gets a lot easier with more practice. I hope you guys found this video useful. If you did, consider subscribing, and thank you for 100 subscribers. We just hit that today, so I'm quite happy about that. If you want more Calculus 1 lessons, consider clicking on this playlist here. That'll link you to all of my Calculus 1 lessons on this entire channel. I'll see you guys in the next video.